Okay, I'm not even 100% sure that we're going to run into too many simultaneous equations in this course, but while I'm smashing out a few of these little maths backgrounders, I thought I would do one on these as well, because they do often come up in physics, and it's a relatively simple technique, but quite a powerful one, so hopefully something that will be useful and interesting. So basically, simultaneous equations are when we have two equations in two unknowns, or sometimes three equations in three unknowns, but that's pretty tough. So I'm going to create two equations here. Now, I can't directly solve either of those. I can't rearrange either equation by itself to find the value of x and y, because there are two unknowns. So all I can do is get an equation that gives me one of them in terms of the other. But what I can do with simultaneous equations is that there are strategies to resolve the two. And basically what you're trying to do is eliminate one of the unknowns and then solve for the other, and then use that to go back and solve for the original one. So in this case, let's call our two equations 1 and 2. Just so that we have them named and can talk about them. And the same rules as apply for all of algebra apply. You have to do the same thing to one as you do to one side of the equation as you do to the other. Now, in this case, we have a few options. We're trying to eliminate either x or y and leave the other one alone. So we could multiply equation 2 by 3. Let's do it that way first. So we'll leave equation 1 alone for the moment, but we'll do equation 2 and multiply it by 3. So multiply everything in that equation by 3. 3x minus 6y equals 6 3s are 18, 3 1s are 3, 48. Okay, so now we could call it 2a, but we won't bother labeling it just now. But now we have two equations, both with a 3x in them. So we can subtract one from the other. So let's subtract, maybe we'll label it just so that we can actually keep track of what we're doing. So call this 2 prime. Let's subtract 1 from 2 prime. So 2 prime minus 1. So 3x minus 3x is 0. Minus 6y minus 4y is minus 10y. 48 minus 18 is 30. So minus 10y equals 30. Divide both sides by minus 10 and to get y on its own, and you get y equals minus 3. Well, y equals 30 over minus 10, which equals minus 3. Okay, so we've actually solved for the value of y, and now we can solve for the value of x. Let's use the simpler one. So this is equation 2 again. And we're going to substitute in the value of y that we've got. So equation 2, x minus 2y equals 16. X minus 2 times minus 3, the value of y, equals 16. X plus 6, right? Minus 2 times minus 3 is plus 6, equals 16. Subtract 6 from both sides, x equals 10. So the full solution is x equals 10, y equals minus 3. Right, so we've actually just solved that system of equations. Just for fun, let's go to the next page and do it the other way around, just to see, because it will still work. I'll rewrite our equations so we've got them. So 3x plus 4y equals 18, x minus 2y equals 16. 3x plus 4y equals 18, x minus 2y equals 16. Okay, so this time instead, what I'm going to do is multiply equation 2 by 2 instead of 3, and get rid of the y's instead of the x's. So if I do equation 2 again times 2, I'm going to get 2x minus 4y equals 32. Right, I've just multiplied everything through by 2. Now, this time I don't want to subtract because I've got plus 4y in this equation and minus 4y in this equation. So what I want to actually do is add them. So I'll add 2 prime, which is my equation 2 modified. In this case, I modified it a different way, plus equation 1. So 3x plus 2x is 5x, plus 4y plus minus 4y is 0, and 18 plus 32 is 50. So if we divide both sides by 5, divide both sides by 5 to get x on its own, x equals 10, which is the same solution that we got before, which is encouraging because it's the same set of equations. It should be the same solution. So now that we know x equals 10, we can sub that back into either of the equations to find the value of y. Let's do it in equation 1 just for the heck of it. So if we go into equation 1, 3x plus 4y equals 18, because this is good algebra practice as well. 3 times 10 plus 4y equals 18. 30 plus 4y equals 18. Now we're going to subtract 30 from both sides. So we'll get 4y. So I'm just subtracting 30 to get rid of the plus 30 there, and I have to do the same thing to the other side. 4y equals minus 12. And then we divide both sides by 3 to get by 4 to get the y by itself. And y equals minus 3, which again is the same solution we got before. X equals 10, y equals minus 3. That really is all there. Oops, that's a horrible 3. I can do simultaneous equations, but I can't write a 3. Y equals minus 3. That really is about all there is to simultaneous equations. I still can't write a 3. There are ways to solve them with matrices and a whole variety of linear algebra techniques that relate to this, but really the basics are eliminate one of the two variables and solve for the other, and then use that solution to go back and solve for the original variable that you eliminated, so that you end up with 2. And as I say, it's more complicated, but you can actually solve a system of 3 variables as long as you have 3 equations. You need 1 equation for each unknown with simultaneous equations, but we would only ever run into 2 equation systems, I think, in secondary physics. So I hope that's helpful and useful and interesting, and have fun with it.